David and Steve are curious to know what the holes and grooves they've noticed on the brake disc surface are needed for. This is why they returned to John, an expert car and brake mechanic who explained the advantages of these special machinings. The braking surface of standard discs is usually smooth, whereas on the discs used in sports or competition cars, it usually has one or both possible types of mechanical processing: holes and grooves. Holes and grooves bring about significant improvements to the performance of the braking system. Improved grip, cleaning and renewal of friction material is assured, dispersion of water, dispersion of gases, as well as better cooling of the braking system. The presence of holes or grooves on a brake disc is an assurance of better grip and undoubtedly faster and more effective response by the braking system. This effect is achieved thanks to the holes and grooves on the surface, which ensure, especially in the initial stages of braking, better yield through a higher friction coefficient. Another important advantage of using perforated and/or grooved discs is the cleaning and continual renewal of the brake pad friction material. Holes and grooves generate a scraping effect that cleans the surface of the brake pad of harmful deposits of material, thereby also preventing tiny residues of ferrous material from brake disc wear becoming embedded in the friction material of the brake pad itself. Holes also help break up the film of water that may form on the braking surface. For this reason, even when driving in wet conditions, the brake system responds efficiently right from the first brake. In the same way, the grooves facing outwards also help ensure more effective dispersion of any water that may be present on the surface of the disc, with benefits in terms of uniform performance in all weather conditions. Just as holes and grooves help disperse water, they also ensure better dissipation of the gases that form at high temperatures between the surfaces of the pad and disc. These gases are caused by the combustion of the resin used to manufacture the friction material on reaching high temperatures. They may cause fading that reduces the friction coefficient between the disc and the pad, with consequent loss of braking efficiency. The presence of holes or grooves on the braking surface helps achieve faster expulsion of these gases and rapid return to optimal braking conditions. Lastly, the presence of holes or grooves brings about an improvement in the heat dissipation capacity of the disc and pad, with an improvement in performance of the overall braking system. Discs with holes and grooves are an evolution of standard discs, originally developed and used by all racing teams to enhance on-track performance. These improvements were subsequently also implemented on production cars having motorsport characteristics and ultimately proposed as a better performing alternative to standard braking systems for more enthusiastic drivers. Developed in order to improve performance, perforated or grooved discs in some cases may give rise to higher brake pad wear, depending on the kind of solution adopted in the design stage and the materials chosen for the pads. Holes and grooves offer the same advantages in terms of performance. Racing cars increasingly use the version with grooves, since they provide a better effect in terms of water and gas dissipation, while sport versions of production cars more frequently go for the perforated solution, which is less aggressive as regards the friction material on the brake pads. Lastly, from the point of view of appearance, the perforated version is preferred, given its more sporty look. Bearing in mind that such processing affects and weakens the structure of the disc, it is evident that design and production stages are vital in achieving a product capable of ensuring maximum reliability in terms of strength, performance, durability, and above all, safety. During the design stage, it is important to investigate for each specific disc the number, size, shape, and position of every hole and every groove. Thereafter, the machined disc must undergo dynamometric bench and on-road tests to ensure maximum performance at all times and in all driving conditions, while equally meeting all the safety and strength requirements expected by car builders. Consequently, for a disc with grooves or holes or both types of machining to be synonymous with performance as well as safety, it is advisable to contact companies boasting consolidated experience in disc design and manufacture. Keep up to date at bremboparts.com. Brembo, technology and sharing.